Hey guys, all right, I'm going to give you notes for 2.6 and then we'll work on them in class. Share my screen and we'll get going. Okay, so in 2.6, we're going to start analyzing these functions so before when we used calculators, we would graph a picture or a graph and we'd find out the max and min and we'd find out where it's increasing and decreasing and stuff like that. So when we move on and we're doing calculus, we're going to find these things without using a calculator. We're going to do it using derivatives. Okay, so this is really exciting. We're like really getting into the meat and potatoes of analyzing functions without calculators and applying our calculus rules of slope. Okay, so last time we learned about the candidate test for finding absolute max and mins. Today we're going to learn about the first derivative test to find local max and mins and also where the function is increasing and decreasing. Okay, so we're going to create a sign chart, and the things that are going to go on the sign chart are the domain restrictions. So this is where the function is restricted, and then the critical numbers, which is where the derivative is 0 or where the derivative is undefined. Okay, domain restrictions cannot be critical numbers. So we're not going to count those as critical numbers, okay? When we draw an F prime number line, we're going to have the critical numbers and the domain restrictions on the same number line, okay? And we're going to create a sign chart, and then where it's positive, it's increasing, and where it's negative, it's decreasing, okay? So let's go through some examples of this. I'll see if I can zoom and make that a little bit bigger for you. Okay. So this instruction says find the intervals on which these functions are increasing and decreasing and find all local extrema points. So because it says local, we know we're looking for relative, or local is the same thing, okay? So I know from this, the 2/3, that this is a Siegel type graph, but then because it has this x squared, it's probably going to have a little bit more character in it, okay? So let's start by finding our domain restrictions, okay? So if I look at my domain restrictions, this is to the 2/3 power. So I'm looking at a cube root. And do I have any domain restrictions at this point? We don't, okay? So there's no domain restrictions here. So I'm going to write no domain restrictions so that you know I looked at that. Okay, and then we're going to look for where the derivative is equal to 0, just like yesterday. Okay, so the derivative f prime of x, I'm going to take the derivative of this. So this is a mama and a baby, so this is a chain rule. Okay, so the mom is the 2/3, and we keep the inside the same. So I do 2/3, and then x squared minus 9, I keep the inside the same. Now I multiply by the derivative of the inside, or the derivative of the baby, right? So the derivative of x squared is 2x. Okay, so now I need to find out where this equals 0. Remember, we always write this step to show our work. So 2 times 2 is 4, so this is 4x divided by 3, and then because this power is negative, it puts it to the bottom, and it's a cube root. Okay, so this is what I'm trying to find out, where this is, where the critical numbers are. So where is this 0 and where is this undefined? So the critical numbers, first of all, if I plug a 0 into the x value at the top, I'm going to get a 0 for the function. So critical number is 0, and then the bottom cannot be 0. So this is going to be 0 if I have a 9 right here, right? So 9 minus 9 would give me a 0. So I can't get a 9 right here, and the values that will give me a 9 are -3 and +3. So these are the places where the function is undefined. Okay? And then 0 is where the function is 0. Not the function, but the derivative. So I should write f prime is undefined. Okay, so we've done all this. So the new part is creating an f prime number line, okay? when I look for local extrema, we don't use the candidate test, okay? We create an F prime number line. So I have to think about, what is an F prime number line really graphing or giving me ideas about? Well, it's going to give me the slope. So I'm going to put all the domain restrictions, which there are none, and all the critical numbers down on this number line. So I've got -3, 0, and 3. Okay, so those are the restrictions. So I have to remember this is an F prime number line. And so when I do my sign chart, I'm looking at F prime. Okay, so this is what we're looking at for the positives or the negatives. Okay, so I can do my sign chart just like normal. I can put a minus on the left and then a plus on the right. So everything to the left of -3 is negative, and everything on the right is positive. Okay, so I took care of -3. Now I'm going to scoot over and I'm going to do 0. So everything to the left is negative and everything to the right is positive. Okay, then I'm going to scoot over and I'm going to do 3. So negative, 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 and positive. Okay, now if I multiply this negative times negative times negative, I get a negative. If I multiply negative, negative, and a positive, I get a positive. Here we get a negative and a positive. So you have just created an F prime number line, and this is going to be justification that you need when it asks for justification on this, okay? So this is my F prime number line. So now I can kind of look at this and say, okay, between -infinity and -3, my derivative is negative, which means it's going downhill, right? Okay, and then between -3 and 0, it's positive, so that means it's going up. At 0, it's negative again, so then it's going down. And then at 3, it's positive again, so it's going up. So my original graph is going to look something like this, okay? It's going to decrease, then increase, then decrease, and increase. And I can look at this and I can say this is going to have a relative min at -3 and at +3, and it's going to have a relative max at 0, okay? And then I can also say it's decreasing from -infinity to -3 and from 0 to 3, and it's increasing from -3 to 0 and from 3 to infinity, okay? So we don't have to even use a calculator to graph this or even create a table. I can draw a sketch of this just like this, okay? So this says find where it's increasing and decreasing. So I'm going to write increasing and decreasing. And then it wants to know the max, and this is relative. And I'm not going to have you write relative every time, but I do want you to understand that I'm doing relative max, which is the same as local. Okay, so this is not our absolute. All right, so it's increasing where the slope is positive, so from -3 to 0. And then it's increasing from 3 to infinity. Okay, and then it's decreasing where the slope is negative, so -infinity to -3 and 0 to 3. And I hope you can understand that connection of why that's going to decrease if the slope, if I know the derivative at that point is negative, and the derivative stands for the slope of the tangent line. So if I continue to draw little tangent lines, they would be negative, okay? Then our relative min is going to occur at -3, and I need to plug that into the function and see what it is, and +3. And this says find all local extrema points, and so points means ordered pairs, okay? So our maximum ordered pair is 0, and then I have to plug 0 in to find that. So when I look for the y value that corresponds with our min or max, I'm looking at the actual function, okay? So I'm going to plug in -3 into my actual function. So if I go back up to the top, if I put a -3 right here, I'm getting 0. If I put a +3, I'm getting 0. So my relative min is going to be -3, 0, and 3, 0. Okay, and then if I plug a 0 in for x, then I'm looking at -9 to the 2/3. I don't have to figure that out. I'm just going to write, I'm going to a little bit more room here. I'm just going to write -9 to the 2/3. Okay, that's what my relative max would be. So now I could go in and mark these points on a graph, and I could sketch a graph using that information. Okay, so if you want to write some little notes down from what you learned here, is that when the slope, so that's f prime, is negative, the function f is decreasing. Okay, and when the slope, which is f prime, is positive, the function is increasing. Okay, so we're able to identify that using the slope. All right, let's do it again. So x minus 2 sine x, does this one have any places where it is undefined? No, it does not. Okay, so this is no domain restrictions. Sometimes we get going and we forget to do this extra step, so that's why I'm writing it, okay? So no domain restrictions, and then I want to find out the critical numbers, so f prime of x equals the derivative of x is 1, the derivative of 2 sine x is 2 cosine x. Set that equal to 0. And we get 1/2 equals the cosine of x. So our critical numbers is where the cosine is 1/2. So cosine's 1/2 at our thirds, and this is positive. So pi thirds is on the right, and 5 pi thirds is on the right. Okay, so I'm looking at pi thirds and 5 pi thirds. Okay, so now I'm going to look and see if the derivative is ever undefined, and it's a cosine graph, so it's never undefined. It's a smooth, continuous curve. Draw an f prime number line. Here's pi thirds. Here's 5 pi thirds. This one has stopping points, so I'm going to put a 0 here and a 2 pi here. Not going to change anything. It's just going to be 0 instead of negative infinity. Okay, so on the left of pi thirds is negative, and the right is positive. Scoot over to 5 pi thirds, negative, negative, positive. Okay, and I want you to notice one other thing, is that this function has a negative in front of my cosine. So there's a reflection here. Anytime you have that reflection, you have to put a row of negatives. Okay, because it's going to reflect. So instead of being up here, it's going to be down underneath. So I need to show that on my sign chart. So negative times negative times negative is a negative. I always like to circle it so I know which one it is. This one's positive and this one's negative. Okay, so decreasing, increasing, decreasing. That shows us where our max and our mins could be, okay, and where it's increasing. So it's increasing where this is positive, so from pi thirds to 5 pi thirds, okay, and then it's decreasing from 0 to pi thirds. So notice I put 0 instead of negative infinity, and then from 5 pi thirds to 2 pi. Okay, so that's all we have to do for increasing and decreasing is look where it's negative, positive, negative. So negative is decreasing, positive is increasing, negative is decreasing again. All right, so now I have to do the relative min and the relative max. Okay, well, the relative min is going to be at pi thirds, and the relative max is going to be at 5 pi thirds. And then I have to plug that in to my original function, x minus the sine of 2x. Okay, so pi thirds minus the sine of pi thirds. The sine of pi thirds, so I'm just going to write pi thirds, minus, okay? And then the sine of pi thirds is, I'm going to give you a second to think about it. The sine of pi thirds. I know you got it. Root 3 over 2. Okay, so pi thirds minus root 3 over 2. Did I get that right? I hope I did. Okay, and then we're putting 5 pi thirds minus the sine of 5 pi thirds. Okay, well, what do we know about 5 pi thirds? We know that it is down in the fourth quadrant. So the sign is going to be negative. So instead of putting minus root 3 over 2, I'm going to put plus root 3 over 2. Okay? So that would be our relative max and our relative min. All right. Let's look at another one. Okay, so this one we've got f of x equals x to the fourth plus 3 over 3x. So my domain x cannot be 0. Okay, I know x can't be 0 because if I put 0 in the bottom, I get undefined. Now, I need to know what the derivative is. So to do the derivative of this, I do, what would you do? Good, the quotient rule. Bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. All right, so you're looking at this and you're saying, this doesn't look very pretty. I don't want to know, how am I going to know where this equals 0? Okay, so basically where this function equals 0 is where the top equals 0, right? So if I go ahead and I'm going to simplify it a little bit, this is going to be 12, 4 times 3 is 12, x to the fourth, minus 3, x to the fourth, minus 9. Okay, one more time, 12 minus 3, so this is 9x to the fourth minus 9. So now I'm going, okay, it's not as bad as I thought it was going to be, okay? And then I can take a 9 out, and I get x to the fourth minus 1. And if I factor that, ding, 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 I know this is a difference of squares. And one more time. All right, we've got all that goodness. So x squared plus 1, x minus 1, and x plus 1. Okay, and this is divided by 9x squared. The 9 would cancel out. The x squared is going to cancel out. It doesn't really matter, right? I'm not going to keep writing that because I know if this is 0, then the bottom will cancel out. So I'm just looking at the top. Okay, so now I'm going to say, all right, so if I set this equal to 0, I'm going to get x equals 1 and negative 1, and then the square root of negative 1, which is an impossible answer, it being an I, right? So I'm only looking at negative 1 and positive 1. I already said my domain restriction was 0, so I don't need to worry about the derivative being undefined at 0, okay? So my critical numbers are 0, 1, and negative 1. All right, so I know where my critical numbers are, so now I do an F prime number line. Negative 1, 0, and 1. Okay, what do you know happens at 0? I know that it's undefined at 0, so it's going to be an asymptote, okay? Or a hole, something like that. So now I'm going to make my F prime number line same exact way we did every other time. Minus, plus, 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 minus, minus, plus, plus, minus, 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 plus. Okay, hopefully you're getting that down. So does this one have a reflection between the x to the fourth? So, oh, sorry, I'm looking at the wrong one. I'm looking at the wrong one. So at this one, our derivative. Does the derivative have a reflection? No. So, but one thing you do need to notice is that this 0 has a square on it. So anytime I have a repeated 0, I have to do that value twice. So my first 0 is negative, negative, positive, positive. I also have to do negative, negative, positive, positive one more time because of that 0 was repeated. Okay, so this is actually going to be plus, minus, plus. I just did that wrong. Minus again. And plus. Okay, so plus, minus, minus, plus. That means this is going to increase and decrease, and then it's going to keep decreasing and then increase. Okay, so that's okay. It just means that at 0, there's not a max or a min. Okay, so sorry, I'm trying to open up my messages so that the chat doesn't keep beeping in our video. All right, so we've got plus, minus, minus, plus. Is that where I was? Okay, so now I have to say, all right, where is this increasing? So this is increasing, decreasing, decreasing, and increasing. Okay, so it's increasing from negative infinity to negative 1, and from 1 to infinity. Okay, and that's okay. It can do that. This is decreasing from negative 1 to 0, and from 0 to 1. Okay, now for our relative max, that's going to happen here at negative 1, and our relative min is going to happen here at positive 1. Okay, go back to the original function and plug a 1 in. I can probably do that without showing work. So 1 plus 3 is 4, divided by 3. So this is 4/3. And then if I do it here, I'm still going to get a 4, but then I'm going to get negative 3. So negative 4/3. Okay, the very last thing that we have to do one more. Sorry, I forgot I put it on 2 pages. Okay, so one more of these, and we get, this is a cube function, so there's no domain restrictions. Okay, and then I have to find where the derivative is undefined or 0. So 3x squared minus 6x plus 3. Where is that 0? Well, I can factor that, right? So remember, we're supposed to be able to do these without a calculator. So practice, brush up on your factoring skills, because you're going to have to factor a little bit, okay? So this is actually going to be x minus 1 and x minus 1. Okay, so this is important that you notice this, that the derivative has a repeated 0. So when I do my number line at 1, I'm going to have to show that twice, just like we did with the 0 on the other one. Okay, so here I'm going to have my function equals 0 at 1. Okay, so my critical number is 1, and that's it. So when I do my f prime number line, I have a thing at 1, okay, and then I say negative, positive, but remember I have to do it again because the derivative was repeated. So if I wrote this derivative, f prime of x equals 3 times x minus 1 squared, then that 1 has a multiplicity of 2, which means I have to do it twice for the 1. So this is both positive, so it's just like this, right? So what that means is it's increasing from negative infinity to positive infinity. It's never decreasing, and there's no relative extrema. Okay, there's no relative extrema. It's not going to have a max or a min, and it's never going to change direction and increase and decrease. So if I look at this x cubed minus 3x squared plus 3x, it's just going to be, we'll just keep going like this. It's not going to dip and go up. Okay, when a function does this, where it's always increasing or always decreasing, it's called monotonic. okay? It's always increasing or always decreasing. They call that monotonic, okay? Couple of things that example 4 tells us is that every critical number is not always a max or a min, okay? And then even though the slope at 1 is 0, the function is always increasing, okay? So a couple things you learn from that. So basically, that you don't always have to get an increasing, decreasing, or a max and a min. That's okay. It just means that your original function isn't doing that, okay? All right. Go ahead and work on that, and I will see you in class.